Good morning, class. Good morning, everyone. How are you all doing? Okay, thank you, Aditya. Okay, thank you. Good morning, everyone. We there? Hello. You disappeared. Sleeping? Watching other channels or what? Manish, Deepika, good morning. Good morning. Shahrukh. Laws of chemical reactions not said. Pula, I mean, that law of chemical combination that you have to read from that NCRT beta. I'm asking everyone to do it from the NCRT itself. And whatever we are doing, they are nothing but the application of the same laws. So you please do it from there itself. Getting it? And if you have got anything, you can let me know that stuff. I'll handle that. Okay? Okay, Sham? Good one. So we'll be focusing on the core part, or like what NEET can ask you people. Okay, something which is very much like obvious, we can handle that ourselves. If there is anything which we cannot, we will be doing that in the class itself. Good morning, everyone. So we begin the class right now. Chalo, aajao, come on. So today is a very important day. Today we'll be beginning the concentration terms, and they are the backbone of the entire physical chemistry. So we'll begin with the concentration terms today, and I'll tell you what. The first one definitely will be molarity. But remember that, suppose, why this is so important? Like this is a solution of say HCl. Getting it? You can take any solution. This solution will have its own molarity, will have molality, so also small m, will have normality also, will have like say percentage weight by volume, will have percentage weight by weight, might have mole fraction of it, and a mole fraction of B. Like they are all different concentrations terms, but of the same solution. Since they define the same solution, there must be some connection between molarity, molality, normality, percentage weight by volume, percentage weight by weight, and mole fraction. Yes or no? So anyone who is able to connect the molarity with molality, normality, percentage weight by volume, this one and that one, will become the champion of physical chemistry. That is for sure. So what is your job? To understand what the concentration terms means and what is their interrelationship. Anyone who is able to do that properly will become the master of physical chemistry. Is that clear to all of you? Is that clear? And they're all very closely related. There is no need to learn formulas also for that. If we are using common sense, we are able to visualize the concentration terms, it will become very easy. So today we'll be beginning that journey. Okay? And why it is important to understand what I'm saying? Because remember that if your concentration terms are stronger, this can happen to you people. Like say from the pure mole, they will be asking you hardly one question in one examination as such. So suppose they're giving you 18 questions from the physical chemistry. So I'm saying that if you leave atomic structure and atomic structure as such, and what else, maybe some states of matter, I believe that almost all other chapters will be using the concentration terms. For example, this chapter itself right now, we are beginning with concentration terms. So yes, it is the concentration. Then thermodynamics. There are certain sections of thermodynamics, thermochemistry, which you cannot handle if you do not know concentration. Then comes chemical equilibrium. This chemical equilibrium is actually 100% all about concentration terms. Then we have got ionic equilibrium. Ionic equilibrium is all again 100% of concentration terms, especially the normality. Then we have got a chapter called solution. Solution chapter is the only chapter which uses almost all the concentration terms. You will be using that. Molarity, molality, mole fraction, percentage weight by volume, all of them. So in that chapter, whatever skills we will be learning right now will be utilized there. Then comes electrochemistry. electrochemistry and chemical kinetics, all of them will be using all the concentration terms. And when we will do the electrochemistry, perhaps almost last chapter, it will be using not only concentration terms, it will be using every chapter except chemical kinetics and atomic structure. So electrochemistry will have some input of thermodynamics, some input of chemical equilibrium, some input of ionic equilibrium, some input of solution. Every chapter will be involved in electrochemistry. So this is all interrelated. So if you ask anyone a question, sir, which chapters are important? Boys and girls, you're asking a very wrong question at a very wrong place. And answers might be terrifying for you. Are you getting that? So this is all interconnected. It's simply that who are you? If I ask you, if I remove your head, your heart, your lungs, then who are you? Nothing. So we cannot prepare any entrance test only on the basis of the organs. Basically, human being is more than the sum of the organs. If I collect some organs and place them together, I cannot make a walking, talking and thinking human being. Same happens with the subject also. So sir, I want to leave ionic equilibrium, I want to leave thermodynamics, then boys and girls, you are moving straight away into hell, live hell. And we can't afford that. Is that clear to all of you? So this is all connected. Try to connect it, try to visualize it. It is actually simple if you want it to be done. Thank you, Shyam. Thank you so much. Arre, respond to kariye. Sometimes I really doubt that you people are sleeping or doing something else. What? You can tell me, I won't share with anyone. Tell me. You can tell me on the YouTube live, but I won't share with anyone. Is concentration terms are there for the weekend? Sanjana Reddy, they are not for the weekend, but they are for every other weekend, every other unit test, every other major, every other grant test. So what you want to do? You want to trade that? That since it is not coming, I won't do it. And please don't pay too much of attention to the weekend test. Please keep on paying attention to the larger picture. The larger picture is NEET. So if you focus too much on the weekend, you might miss the larger picture. You are the larger picture. This is the one more larger picture for you people. Getting it? Okay, that's good. So we are beginning now. Okay? Chalo. Okay, bye. May 5th this time? Okay, done. You guys are rock stars, I'm not. So we'll begin with the molarity. First concentration term, molarity. Capital M. Okay? So what is, before I begin, I want to share that I'll be using certain terminologies for this stuff. Okay? KB Reddy, you are a hero. Look at her. Dekho bachcho. There is something called solvent and there is something called solute. When you prepare a solution, it is composed of solvent and solute. So I'll make sure that solvent will be called A and solute will be called B. Is that okay? Chalo. And now, if I want to write down moles, I'll write down moles of solvent as Na and this as Nb. If I want to write down the weight, I'll write down Wa and Wb. It will make us more efficient and faster. Okay? And then molecular weight will be written as Ma and Mb. Ma and Mb. A means solvent, B means solute. Simple as that. And then there is something called mole fraction. I'll teach you later on. Mole fraction. Mole fraction beta means xi A and xi B. Xi A and xi B. Okay? It's not XA, XB. It's not a right terminology. It's a xi A, xi B. Is that clear? So once that is clear, I believe that molarity is defined as number of moles of solute upon volume of solution. Volume of solution in liter. Volume of solution in liter. That's important. So boys and girls, tell you one thing. Can I say this NB, number of moles, can be written as weight upon molecular weight of solute divided by volume in liters. This VL means volume in liters of solution. Remember that, okay? And then we have got molarity equal to WB upon MB, and this volume, if it is in ml, must be multiplied by 1000. Must be multiplied by 1000. Yes or no? Because in order to convert the volume in ml into liter, you will have to divide by 1000. Yes or no? चलो चलो करो. Okay, okay. Now understand this thing. Very, very important. All these concentration terms are ratios. Very important. You remember that I told you that for gaseous reaction, that volume ratio is also the mole ratio. Volume ratio is also the mole ratio. For example, if I say that number of moles N1, N2, this ratio is like say 1:2. So can I write down this as 2:4 also? Can I write down this as 3:6 also? 10:20 also? I'll get the same ratio. What is that ratio? 1:2, simplest one. That means to get the same ratio, I have got infinite ways. Boys and girls, tell you one thing. If I got like say A upon B is say 1/3. Can I write down 2/6 or 3/9 or maybe say 10/30? I'll get the same answer. They are simply ratios, and there are infinite ways to get the same ratio. So all the concentration terms are actually ratios. How come? Understand this thing. Say molarity is equal to NB upon volume in liter, it's a ratio of moles upon volume. And we have small m, molality, it will be NB upon weight of solvent in kg. Don't worry at all if you do not know, I'll teach you this thing later on, but right now understand. It will be again a ratio of number of moles of B upon weight of solvent in kg. Similarly, I can have normality, which is number of equivalents upon volume in liter of solution. Also, we are having Xi B will be equal to what? NB upon Na plus NB. One thing is common in all these concentration terms. All these concentration terms out here and any other concentration term which I have not written here, they are all ratios. Ratio A upon B, A upon B, A upon B, A upon B. And to get the same ratio, there are infinite ways possible. Infinite ways possible. Are you getting it? Suppose this ratio I want as say maybe 2:5. Can I write down this as 4:10? Yes or no? Can I write this down as 20/50? I can write down. There are infinite ways to get the same ratio. Now see, understand the difference between your level of physical chemistry and the rest of India. When they give you like say a 2 molar solution, for rest of the India it is only 2 molar solution, but for you people it is more than that, and that's very important. More information means more command on the question. More command means you are the king now or the queen as per the requirements. Okay, yes or no? How come? See that stuff. Since 2 molar means NB upon volume in liter. This is a ratio. Can I say this is 2:1? 2 moles in 1 liter? Can I say that? Okay. Can I say 4:2, 10:5? Yes or no? 12/6, maybe 13/6.5. All of them. Yeah, correct, beta. Correct. Moles of solid 2 and volume of solution equal to 1. Very good. Very good. So since they all are ratios and there are billion ways to get the same ratio, you can choose anyone, you'll get the same answer. But my recommendation is that you choose the simplest one. The simplest one. The reason being, you can use 1/0.5 also, but again, why to use decimals? The idea is to simplify the mathematics. Always choose the simplest one. your maths will become very simple. That's the entire idea. Are you getting it? All of you? Yes or no, beta? All of you. Come on. Two molar solution, hai na? Okay. Similarly, if I want 1 molar solution, it will be again number of moles of solute upon volume in liter. I can prepare like 1 mole in 1 liter, 2 mole in 2 liter, 4.5 mole in 4.5 liter, 5.7 moles in 5.7 liter, and so on. But the ratio remains same. Which one you will choose? I'll choose the simplest one. I'll choose the simplest one. You can take any one. The idea I'm telling is that to get the same ratio, there are infinite ways. Choose the simplest one. Say for example, when the examiner gives you that I am giving you 2 molar solution, you know that this is NB upon volume in liter, which is 2 upon 1. For rest of the India, it is only 2 molar solution. But for you people, the information will increase exponentially. How come? For you people, this is also number of moles of solute is 2 and volume of solution is also 1 liter. Are you getting it, beta? Not only you know concentration terms, you also know number of moles and volume also. But for many of them, it is simply one data, that is called 2 molar. But for you, it is not only 2 molar, it can be 2 moles in 1 liter. It can also be 4 moles in 2 liter as per the requirements. Yes or no, boys and girls? Come on. This I'll be using multiple times in a chapter called solution, and everywhere. I'll use it to my advantage. So when we learn something, the idea is to get the advantage. So we'll be using for our own advantage. Is that clear? Sure. Chalo. Okay. So the moment they give you 5 molar solution, urea solution, 5 molar urea solution. What is the meaning of that? Not only it is 5 molar, but also something else. What is that? It also means 5 moles of urea in 1 liter solution. Very good. Brilliant answer. Very good, bache. Very, very good. 5 moles of urea in 1 liter solution. So I got the information of volume. I got the information of number of moles also. Sure about it? Chalo, theek, come. So, let me ask you one question now. Let me ask you one question and all of you have to answer it and answer it properly, beta. Like, no, why I like chemistry, you know? Because in chemistry we have got something called solution. And life is full of problems. So take chemistry, put the problem in solution and get the solution. Chemistry gives you solution of all the problems if you have got the right attitude. Will you believe me or not? Wherever there is a problem, there is a solution. And wherever there is a solution, there is chemistry. And wherever there is chemistry, you will find me at a service. You teach chemistry, that's why you love chemistry. Yeah. Why should not I? I mean, everyone should be loving their job. There is no point in doing job which you don't love. Like it's going to a job and like dying every day, every moment. So never ever do a job which you don't like. Like you will be investing almost 50% of your life in your job, in your work. So choose it carefully. Just because others are telling you don't do it. Abhe, अगलों की तो बैंड बजी हुई है, तुम्हारी भी बैंड बज जाएगी यार, है ना? दुनिया, that world is more sadistic kind of thing. Most of the people are unhappy in their services and they still they keep on poking you. They keep on poking you. यार तू भी कर ले, तू भी कर ले, तू भी जॉब कर ले, कौन सी कर ले, तू ये वाली कर ले, तू वो वाली कर ले. नहीं, ऐसा नहीं करना. Do what you love. ठीक है? I believe that the marriage and the job should be done as per something you love. And it has to be like pure love, not the infatuation kind of thing. Yes or no? We love biology, that's why we love doctor. That's good, that's even better. That's even better. But you will not become doctor without loving chemistry. So you have to love chemistry, which likes almost 180 marks. So it will be a very poor trade-off if you neglect chemistry. If you neglect chemistry, you are neglecting me. And you neglect me, I don't like it. Getting it? No, it's not as if I like only physical chemistry. I like organic and inorganic also. Okay. No. Not only physical. Multiple things. I like many things. Don't worry at all. I'm good at studies, so I keep on doing a lot of studies. Chalo, aa jao. Shampoo is like becoming more philosophical. We love all subjects. That's why we love NEET exam. Could keep it up. You are all rounder. Sir on fire. अरे तुम इधर देखो, तुम लोग पता नहीं क्या कर देते हो. I mean, you guys distract me also by your comments. चलो इधर आ जाओ. So come on over here. Come over here. Here we go. Okay, so let's begin some questions now. In one shot. चलो आ जाओ बच्चों. So we are doing some questions right now. Come on. So I told you one thing, that there are a billion ways of preparing a concentration. है ना बेटा? Same concentration can be achieved by multiple ways. So chalo, before doing question, I'll give you one more example to make you understand beta. Okay? Chalo, देखो बच्चों. Please come. Let's suppose I gave you a call. I called you, and whom should I call? Anyone will volunteer. So I'm taking that. I called Shrikar. So I called Shrikar out there, and Shrikar said, "Sir, you can please come to my hometown, and I'll invite you on a coffee kind of thing." Okay, I said yes. So I called you when I came to your hometown. I said, "Shrikar, I'm in your hometown. I want to have a coffee with you. Can I come?" He says, "Sir, you can definitely come. My mom will be preparing the coffee, and she's very good at that." Go, okay. So I accepted the invitation. So his mother basically, she was already on the gas burner, and all that milk and the coffee part was there. So she was preparing a coffee of some sweetness level. So all of a sudden, Shrikar gets call from 20 more teachers of Sri Gosalite, for example, and they all say, "Why you are giving special treatment to Chauhan sir? We are also coming to have the coffee. Please ask your mom to prepare the coffee." So my question is that, will your mom Shrikar will be able to make a coffee of the same sweetness for all the 20 more teachers coming that she was preparing for me? Can the sweetness level she was preparing for me will be the sweetness level she will be preparing for all the teachers? Is it possible for her? Is it possible for her? If she is preparing a cup of coffee for me of some sweetness level, and now she has to all of a sudden make coffee for 20 more people, can she prepare a coffee of same sweetness she was preparing for me? Is it possible? No. Okay. Then let me tell you one thing. Never underestimate the power of a mom. Mom is very powerful, very, very powerful. And she is the only one in the house, in the home, who knows entire chemistry without knowing the formulas and the chemical structures of that stuff. But she is extremely accurate with that. We will be using, like say, beaker, all those measurements will be there, but she will be using simply hands, and she can prepare the coffee of same sweetness for not only 21 people, but for n number of people. How come? Let me tell you one thing. Come on. So if you ask your mom that, "Mom, do you know molarity?" She will say, "No, I do not know." "You know molarity?" "No, but I do not know." "Mom, you know normality?" Now it is too much of insult. She said, "I do not know." "Mom, you know mole fraction?" She may not know mole fraction, but she can give you a chappal flat on your face. So never ever try the patience of mom. Mom are very short on patience sometimes. Getting it? And when you're testing their knowledge, don't even test it at all. Okay, now say what I'm saying. Like say for me, she was preparing a coffee basically, that 1 spoon of sugar and 1 cup of milk, for example. Yes or no? So when the 20 people are coming, what she will do to prepare the same sweetness of the coffee? Come on, 20 spoonful, and then 20 cup of milk. And not only this thing, if she has to prepare for 100 more people to come, she will be using 100 spoonful of sugar and 100 cup, exactly same sweetness level. You are underestimating your mom. Never ever do it. Never ever. They are the powerhouse. They are the lifeline of every family. No mom, no life. Yes or no? And chemistry is the right place to understand the importance of a mom. Yep. Okay. You simply said no, but I mean, she's expert at that. She's expert at doing so everywhere and now. Okay? Chalo. So simply, with the help of coffee, basically your mom is trying to teach you something that we can have same concentration by n number of ways. Okay? Chalo. Come on. So question number 1, we have 60 gram of urea in 1 liter solution. In 1 liter solution, what is the molarity? So molarity will be WB upon MB, weight of solute upon molecular weight of solute, and volume in liters. Okay, so 60 upon 60 and 1 cancels up. This will be what? 1 molar solution. 1 molar solution. Great, very good. Chalo batao. Next question. Come on. 30 gram urea in 500 ml solution. 500 ml solution. Come on. Molarity now will be weight 30 upon molecular weight, and volume, if it is in ml, multiply by 1000. 2 times and 2 times and cancel. Again 1 molar. Yes or no? The ratio remains same. So there are right now 2 methods of preparing 1 molar urea solution. Are you getting it? Here you have made the weight half. Weight has become half, so has become the volume of solution. So ratio remains same. Volume has become half and number of moles have also become half. Ek aur question karenge. One more question. It is like, say, 15 gram of urea in what 250 ml solution. 250 ml solution. Find the molarity. Come on, find the molarity. Come on. One molar, same. Ratio remains same. Number of moles have become 1/4, so has become the volume as well. So molarity will be 15 upon 60, 250, and this will be what? 1000. 4 and 4 cancels, again 1 molar. So this is a third method of having 1 molar urea solution. Similarly, there will be infinite ways of preparing 1 molar solution. Every concentration term is a ratio, and to get the same ratio, there are billion ways, infinite ways. Are you getting it? Okay, chalo, who will tell me a question, please? Let's say we are having 2 into 10 to power of -3 moles of NaOH in 400 ml solution. 400 ml solution. Find the molarity. Come on, do it. Find the molarity. Do it quickly. Do it quickly. Same, very simple, bacho. Molarity is equal to number of moles of solute 10 to power -3 upon volume in ml 400 multiply by 1000. Yes or no? Everyone should give the answer, beta. Everyone should give the answer. Come on. Uzma, Zamir, Kashi, Vishwanath, Sumajra, Shrikar, all of you give the answer, please. Deepika, Manish, all of you. Haritha, Amrutanand. Arey, what happened to these boys and girls on this app, I believe? Hello, Amrutanand, Haritha, you sleeping or what? Arey, Amruta, you are here? Not here today? What happened? Acha, app not working. No problem. Everyone is getting the correct answer. Everyone is getting the correct answer. Keep it up. Keep it up. So this will be there. This will become 2.5, 2.5 into 5. So 5 into 10 to power of minus 3 molar. Yes or no? Durga Prasad का नाम है आज से हरिता. So Harita, you have become Durga Prasad ji. Why so? You don't like that name of Harita? Okay, no problem. It's your choice. I don't mind it. So your brother's account is there. Okay. Chalo, theek hai, okay. Okay, now see this thing. This is important. This is very important. Everyone, please come. Say, beta ek baat batao mujhe. If I take 1 mole of NaCl, I believe that it will give me 1 mole of Na plus and 1 mole of Cl negative. Agree or not, beta? Agree or not? And if I take 2 mole of NaCl, I'll get 2 moles of Na plus and 2 moles of Cl negative. Yes or no, beta? Yes or no? Okay, theek hai. Let's see that stuff. Acha, who will tell me if I take BaCl2 will give me 1 Ba2 plus and 2 Cl minus. Yes or no? Yes or no? That means if I take 1 mole of BaCl2, I'll get 1 mole of Ba2 plus and 2 moles of Cl negative. Agree or not? If I take 5 mole of BaCl2, I'll get 5 mole of Ba2 plus and 10 moles of Cl negative. For every 1 Ba2 plus, I'll get 2 Cl negative. Yes or no? Achha, I believe that if I say a 5 molar solution of BaCl2, 5 molar solution of BaCl2, will you agree with me if I say that this actually means 5 moles of BaCl2 in 1 liter solution? In 1 liter solution. Yes or no, beta? Okay. So can I say that this much of solution will give me 5 moles of barium 2 plus in 1 liter solution and also 10 moles of Cl negative in 1 liter solution? Yes or no, beta? Can I say that? Which actually means this will be 5 molar and this will be 10 molar. 10 molar. That means 5 molar BaCl2 solution will give me 5 molar barium ions and 10 molar Cl ions. Again, the ratio is 2:1. Yes or no? So let's try some questions now. Let's try some questions. So who will tell me that 1 molar NaCl will give me what concentration of Na plus and what concentration of Cl negative? I believe 1 molar and 1 molar. 1 mole in 1 liter. 1 mole in 1 liter. 1 molar. Chalo, tell me. 6 molar NaCl solution will give me what concentration of Na plus and what concentration of Cl negative? I believe 6 molar and 6 molar. Very good, very good. I want everyone to answer, bachcho. Please answer. Everyone should answer, beta. Everyone. Very good. बहुत अच्छे. Good. Okay, come. Now see this thing. Okay, now we'll change the question. I'm coming to BaCl2. है ना? So I'm giving you 2 BaCl2, 2 molar BaCl2. Can you get me the concentration of barium ions and concentration of Cl negative ions? Come on. 2 molar. This will be 2 molar. This will be double. 2 and 4 molar. 1 BaCl2 give me 1 barium ion. 2 will give me 2. 1 BaCl2 gives me 2 Cl ions. 2 will give me 4. That's it. Chalo, who will tell me 5 molar? No, we have done this thing. We have done this thing right now. We'll change this figure. 4 molar BaCl2 will give me how much of barium ion concentration and how much of Cl negative concentration? Come on. 4 molar and 8 molar, double of that. Cl negative concentration will be double of that at any cost. Everyone, I believe. Come on, we'll do one more question, and this time we'll take example of AlCl3. AlCl3. So I'm taking 4 molar AlCl3 will give me what concentration of Al3 plus and what concentration of Cl negative? Come on, everyone, be quick. 4 and 12. 4 into 1, 4 into 3, 12. Chalo, 5 molar AlCl3 will give me what? 5 molar. 5 and 15, I believe. If I am wrong, correct me. 5 and 15. Kavita, which question is answering beta? This question will be 5 and 15. 1 AlCl3 giving you 3 Cl negative. Good. Will improve upon little bit. Come on. Al2SO4 whole thrice. 1 aluminum sulfate will give me 2 aluminum ions and 3 sulfate ions. So tell me, 8 molar Al2SO4 whole thrice will give me what concentration of Al3 plus and what concentration of sulfate ion? Come on, answer it. 8 into 2, 16, and 8 into 3, 24. 16 molar and 24 molar. I hope that will make it very fine to all of you. Can you handle those questions? Good, very good. Chalo, ठीक है. So let me give you a chart for handling the concentration term, है ना? See beta, weight, number of moles, you know, divided by molecular weight. When they give you volume of gas at STP in liters, you can divide by 22.4 liter. And how about this one, beta? If they give you number of molecules, you can divide by Avogadro's number. But if they give you molarity, capital M, how you will reach there, beta? I know that molarity is what? Number of moles upon volume. So number of moles will be molarity into volume. So if they give me molarity, I'll multiply by volume to get number of moles. So from here, I'll be multiplying by volume in liter. Yes, good. Very good. Very good. Everyone getting that? Is that clear to everyone? So, chalo, tell me, if they give you weight, how can you calculate the molarity? Come on. Molarity will be, begin with weight upon molecular weight of the solute. And then this way you have to multiply by volume. Opposite way, you will divide by the volume. So, divide by the volume in liter. If they give you number of molecules, how to get the molarity? They are giving you number of molecules dissolved in the solution. It will be number of molecules upon Na. You have reached here. Now from here to here, divide by volume and volume in liter. So you can travel. I believe you all have become master of traveling this way. Anyway, that's the only way you have to travel to become the master blaster of that stuff. Yes, good, Pavitra, very good. Convert that into moles, and once you get moles, everything is very feasible. Shall I? Okay. So let us do some question now. We become Vasco da Gama. You have become now Vasco da Gama. Correct. Vasco da Gama ji, look over here. So let's do some questions on dilution. So tell me one thing, that if we are here, I have taken 1 mole of sugar. and I'm adding some water. I'm adding some water. I've added some water now, so this has become a solution basically, you know. Say, for example, that molarity will be NB upon V liter. This is V liter, you know, or you can say I'm taking it general. I'm taking it general, bachcho. Rather than taking 1 mole, I'm taking some sugar, NB, and this is V1. You know? So tell you one thing, if I add some water into it, I believe the sweetness will decrease. Yes or no? On adding some water to it, sweetness levels will decrease. Will you agree? Suppose you take some Pepsi and you keep on adding water into it, the sweetness level will go down. So whenever sweetness level go down, we can confirm that concentration is also going down. Why I'm saying that? Because concentration is actually number of moles upon volume. Number of moles of sugar remains same. I'm not changing number of moles of sugar. I'm simply adding water into it. So number of moles remains same. Volume is increasing. And I keep on adding water, the level of water keeps on rising. Volume increases, as a result, concentration will decrease. If the concentration decreases, the sweetness will also decrease. So whenever you are visualizing, more solvent means, solute is same, Sheshagiri. Solute is same. It is 1 mole only. I am not decreasing moles of solute. But at the same number of moles, if volume increases, concentration will decrease. The ratio will decrease. Yes or no? So, can I say for dilution, one thing will remain same. What is that? Initial number of moles of sugar will be equal to final number of moles of sugar. Because I am not changing sugar at all. Sugar is constant. Solute is constant, Shrikar. Very good. Yep, correct. So, can I say that for dilution, initial number of moles NB1 will be equal to final number of moles NB2. Moles of solute will remain same. And if that remains same, can I say this is M1 into V1 and this will be M2 into V2? Yes or no? Because I know number of moles is molarity into volume. N1 V1 equal to M2 V2. Yep, correct beta. So remember this thing. And what is this V2 beta? This V2 is final volume. Final volume. Are you getting it? Final volume. So let's do a question now. So I'm giving you that we are having 10 molar 50 liter HCl solution is diluted to make say 2 molar solution. The question is find the volume of water added. Find the volume of water added. Can you do it? Find the volume of water added. It's a case of dilution. So M1 V1 will be equal to M2 V2, where V2 is the final volume. Come on, 10 into 50 equal to 2 into V2. This will be 25. So V2 will be 250 liter. 250 liter. Yes or no, beta? But this is not the right answer. I'm asking what? Find the final volume. I was asking, find the volume of water added. This is the final volume. Initially, I was having already 50 liter. So, see that thing? If this is 50 liter, you are adding water into it to make it what? Total becomes 250. Excuse me. So how much water I have added? 200. I have added 200 liter of water. So this is called final volume. So volume of water added. 250 minus 50 equal to what? 200 liter. Yes or no? नहीं 300 नहीं आएगा. संजना रेड्डी बेटा. Kusuma, what happened to you people? There's no 300. Sanjana and Kusuma, rectify that. Is that clear to all of you? So let's do some questions on mixing of solutions, है ना? Mixing of solutions. So when you will mix the solution, beta, say we are having two solutions whose number of moles are N1 and number of moles are N2, and you are adding them and mixing them as such, na? So number of moles N3 will be N1 plus N2. Yes or no? And if in this number of moles you add some volume V1, V2, this is number of moles of solute. You add some volume of water. Sir, can I continue online throughout the year? You can. I mean, if you are able to read at home properly, you are able to do the revision without distraction. You are not watching Netflix, you are not watching Hotstar, you are not watching cricket, and you're not doing all those waste of time kind of thing. You can definitely do it. It's up to you. So you will be in a better situation to decide what I should be doing. Chalo. So V1, so it will have some molarity M1. It will have some molarity called M2, and this will have some molarity called M3 and volume V3, where V3 will be equal to what? V1 plus V2. V1 plus V2. So suppose this is like say 2 liter, 4 liter, 2 plus 4, 6 liter. Total volume here will be 6 liter. Okay? So let's do a question basically for that, but before that, let me conclude that. Can I say that N3 will be equal to N1 plus N2? And if that is the case, I believe it will be M3 V3 equal to M1 V1 plus M2 V2. M2 V2. And can I say M3 will be equal to M3 V1 plus V2 equal to M1 V1 plus M2 V2. Is that clear, beta, to all of you? Is that clear? Sir, no law of conservation of mass. No, mass is conserved. Mass is conserved. Bachche, Zamir. No. There is no law of conservation of molarity. Molarity is not conserved. Molarity can increase, decrease. But mass and number of moles will remain same. Zamir. Is that clear? So we'll be using that. Na? We'll be using this thing in handling questions. Chalo batao. I'm doing 2 molar 5 liter HCl plus 3 molar 4 liter HCl solution. When they are mixed, find the final molarity. M3 equal to no. Srinivas, we can never do it. Srinivas is asking, sir, can I write down that M1 plus M2 is equal to M3? No, this does not happen. No, we cannot add molarity directly. It is an intensive property, and intensive properties cannot be added directly. I'll teach you this thing in thermodynamics also. We can only add those things for which there is a law of conservation. Law of conservation of energy. Energy can be added. Conservation of mass can be added. Getting it? But concentration is not conserved. Concentration can increase or decrease. Chalo, theek hai. We are mixing that. So it will be M3 and V1 plus V2, 5 plus 4. 5 plus 4 equal to M1. What is that? 2 into 5 plus 3 into 4. So M3 into 9, 5 and 4, na? Theek hai. Will be equal to 10 plus 12. So M3 will be 22 by 9. Whatever it is now coming. 22 by 9. Okay? Is that clear, beta? Is that clear? So you can definitely gently practice these questions. I'll carry on from here onwards. Na? We'll carry from here onwards. We'll do more questions on molarity in the coming lectures. Na? But just go through it and prepare for the weekend test properly. Sir, mixing is possible only for same solution. No, you can mix multiple solutions also. We'll do some questions on there, that part also, but in the next class. Okay? We can make HCl and NaOH also. We can mix HCl and H2SO4 also. We can mix anything. We can mix anything. We are very good at mixing. Yes or no? A DJ kind of thing. You can mix anything. Anything. Chalo. Bye, bye. Take care. All the best. Bye bye.